In this and coming slides, I'd like to talk about functionalization of carbon nanotubes and different kinds. As you can see in this picture, there are so many ways to functionalize carbon nanotubes, but there are mostly two ways, endohedral and exohedral. As you can see, endohedral is just putting nanoparticles, or the particles that we require or want to functionalize the carbon nanotubes with. We put them inside the carbon nanotubes, and in the exohedral, we attach them to the surface of carbon nanotubes. As we know, CNTs have high mechanical strength, thermally and electrically high conductivity. They're extremely light, and they have so many fantastic properties. To apply these fantastic properties into the nanocomposites and make them soluble, we have to functionalize them. And in the coming slides, I mostly talk about how we can functionalize carbon nanotubes to be able to solve them in a liquid form. So endohedral functionalization is modification of carbon nanotubes by putting nanoparticles inside the tube. And by doing that, we usually change the hydrophobic structure to hydrophilic and make it soluble in the nanocomposites that we would like to apply. So by doing that, we add the properties of carbon nanotubes to the properties of the material that we are mixing with. So as a result, we have a material which contains both properties, CNTs, and also the characteristics of the material that it's mixed with. So this process itself is subcategorized into two methods. The first one is putting this carbon nanotube inside the suspension of containing nanoparticles. Those nanoparticles, that solvent can penetrate inside the tube, and it gets trapped. And what happens is that when it's trapped, it stays inside the tube and doesn't come out. As scientists show, depending on the surface tension of the liquid that we are putting carbon nanotubes in, if it's less than 200 millinewton per meter, it can go inside. The liquid can fill the nanotube, unless it's not possible to do this procedure. The second method is that it's like the nanotube itself, the carbons on the sidewalls of carbon nanotube, they actually react with the nanoparticles and as a result the product and the yield will be trapped inside. So these two methods are the two available endohedral methods, functionalization methods. In the next slide, which is exohedral functionalization, we'll mostly talk about how to functionalize and what are the methods on the sidewalls of carbon nanotubes. Exohedral functionalization is modification of the external part or the sidewall of CNTs. This method itself is subcategorized into three main methods. The first one is covalent exohedral functionalization, or defects. As we know, defects on the carbon nanotube sidewalls are the best place if we want to functionalize. They're the best place. There is an example of that which we see here, which is called a stone wall. As you can see, we have more atoms in comparison with the neighboring atoms. So it's called stone wall. So that in these stone walls we can attach the functionalized group. The second group, which is the covalent exohedral functionalization, we can attack functionalized groups they're mostly used in bio applications. They're microorganisms. There are some groups biomedical groups or carboxyl group, depending on the chemical group. They're attached to the side walls, and this one is called functional group exohedral functionalization. The third one is non-covalent exohedral functionalization, which is polymer wrapping. There is a question here, and by wrapping a CNT inside a polymer, what happens is that the pi orbitals of these two materials they interact, and as a phenomena, something happens called pi stacking. So what do you think? I mean, do you think that this material can be stable or not? The answer is that because of the pi orbital interactions between these two materials, the yield has the less stability in comparison with normal carbon nanotube, which is not functionalized. So it has less stability, this kind of material. I mean, these kind of actually functionalization, and it's not gonna last long. So but it is a form of functionalization. There are also so many chemical functionalization. There are so many, but we actually chose only two of them that we will discuss. One of them is amidation, and the other one is the fluorination of carbon nanotubes. By amidation of carbon nanotubes, we actually attach an amide to the which actually we attach a functional group that I talked in the previous slides. The functional groups that we attached in the exohedral functionalization. Here we can see an amide, which is the RC, which has a double bond with O. If this material is actually bound to a nitrogen, we call this an amide. This kind of functionalization can only be done on the CNTs which already have the carboxyl group. So what happens is that if actually we mix it with thionyl chloride, it will substitute, it will replace the hydroxide part, and it will replace it. The color here will replace it, and as a result we get a CNT which is attached to that amide functional group. The second kind of chemical functionalization is a fluorination of multi-wall carbon nanotubes. As you can see, we have fluor atoms here which are attached to the side wall of carbon nanotubes. This process is done in a temperature for about 150 to 500 Celsius. For maximum fluorination, you have to use pentafluoride, which actually leads to composition of carbon and fluorine bond. Experiments shows electrical resistance of single wall carbon nanotubes has dramatically increased by this method. So I just briefly wanted to talk about one of the applications of carbon nanotubes in water filtration. As we can see, we have azo-dyes, which are the most important materials, which they they are kind of very toxic materials. They accumulate in the nature. They do not go into the recycle, and they trap. They get the energy of light, and unfortunately, they're really toxic to human and animal health. So to remove this material, substance, from the wastewater of so many industries, like pulp, like paper, like textile, everything, these industries waste water, we can use carbon nanotubes. What happens is that functional carbon nanotubes, they have this capacity to be used as a mixture with nanofibers, and they can actually absorb the dyes on the sidewall themselves. How you can see some pictures. As you can see, these are the dyes which are trapped in the carbon nanotubes. That's quite it. I hope you have enjoyed, and I hope you have any kind of questions. If you have any kind of question, you can subscribe to my site and send me a comment or question. I will immediately answer your questions. Thank you. Bye.